In this video, I'm planning to explain the derivative of the trigonometric functions. Here we have the formulas of the derivative of the trigonometric functions. And we should understand first the sin x derivative is going to be equal to cosine x, and cosine x derivative is equal to minus sin x. We have to be careful about the sign. When we get the derivative of cosine x, you should get the minus sin x. And if there is a function inside the sign, sine of fx derivative is going to be cosine fx times f derivative x. So the extra part here is the derivative of the inner function. Here, like in the cosine x derivative is equal to minus sine x it was, and here it is equal to minus sine fx times f derivative x is going to be. Okay, if we start with this question, directly I'm going to apply the formula. This formula I'm going to apply. So cosine fx derivative is going to be equal to minus sine fx times f derivative x. So it's going to be equal to cosine x cubed minus x derivative is equal to minus cosine x cubed minus x times, minus sine x cubed times x times x cubed minus x. Derivative is going to be, that's equal to minus sine x cubed minus x times, here the derivative of the x cubed is going to be equal to 3x squared, and derivative of the minus x it's going to be equal to minus 1. And here this expression, of course, it should be in parentheses like this, because here sine x cubed minus x is one term and 3x squared minus 1 is another term, and this is polynomial function normally. Now we are going to continue with the sine cube x squared. First we should analyze this term here, because sine cube, when you use the cube here, sine cube x squared, this means sine x squared cube. So it multiplies by itself 3 times. Okay, so this is a power rule. First we are going to apply here for the derivative. So f derivative x is going to be equal to sine x squared cubes derivative is going to be, which is equal to 3 times sine x squared to the power of 2 times sine x squared derivative it's going to be. If you remember the rule, f to the power of n x is equal to derivative n times f to the power of n minus 1x times f derivative x. Okay, with respect to that one, I got this result. Then it's equal to 3 sine square x square, and sine fx derivative is equal to, from the previous page, cosine fx times f derivative x. So cosine x squared times x squared derivative, which is equal to 3 sine square x squared cosine x squared, cosine square I have written, cosine x squared times 2x. At the end we can write like this, 6x times 3 times 2x is equal to 6x sine square x squared times cosine x squared is going to be. Okay, the next one, sine x plus cosine x parenthesis square. From the previous question, f to the power of nx derivative is going to be equal to n times f to the power of n minus 1 x times f derivative x. So sine x plus cosine x square derivative is going to be equal to 2 sine x plus cosine x times 2 minus 1 is the power, is going to be 1 now, sine x plus cosine x derivative. That's equal to 2 times sine x plus cosine x times the derivative of sine x is equal to cosine x. The derivative of cosine x is equal to minus sine x, it's going to be, and the expression here sine x plus cosine x times cosine x minus sine x, or cosine x plus sine x times cosine x minus sine x, is going to be equal to 2 times cosine square x minus sine square x is going to be a plus b times a minus b is going to be equal to a square minus b square. And from the trigonometric identities we know this one, cosine square x minus sine square x is equal to 2, here it's going to be equal to cosine square 2 times cosine 2x. This part is trigonometric identity part. Okay, now we are going to continue with the derivative of the other trigonometric functions. Here other trigonometric functions, tangent, cotangent, secant and cosecant. Here tangent x derivative secant square x, or 1 plus tangent square x. Here these two, they are trigonometric identities. That's why if you write like this or like this, there's no problem. They are both same. So tangent fx derivative is going to be tangent fx derivative is going to be secant square fx times f derivative x, it's going to be, and you can read all these formulas here. We have to learn them by heart. So for the questions here, we are going to continue with the questions. I mean, tangent fx derivative I have here, I have to find, and tangent gx also it can be, because fx defined like that. Okay, then tangent fx derivative, it should be equal to tangent, secant square x, secant square fx times f derivative x is going to be. Okay, then tangent fx derivative, here tangent x squared minus 3x plus 1 derivative is going to be equal to secant square fx, it's written, so it's going to be x squared minus 3x plus 1 times x squared minus 3x plus 1 derivative, it's going to be, that's equal to secant square x squared minus 3x plus 1 times 2x minus 3 is going to be. Or you can write 1 plus tangent square x squared minus 3x plus 1 also. Okay, the last one, I didn't explain this part, cosecant fx part I mean, but what was the cosecant fx derivative, if you ask? Cosecant fx derivative, it was equal to, if you remember from the table, you can check the table again and you can see that one, cosecant fx times minus cosecant fx times cotangent fx times f derivative x is going to be. Then if you replace the cosecant fx by cosecant ln x, the answer is going to be equal to minus cosecant ln x times cotangent ln x times ln x derivative is going to be, that's equal to minus cosecant ln x times cotangent ln x times 1 over x is going to be our answer.